since it was your only choice. Okay, right? Okay, so we're going to do an example of a density function. Now, usually we won't use rho for a density per unit length. Usually we'll use a lambda. And, you know, I might as well. Okay?
Rho is for volume, right?
Well, rho is usually used for volume, sigma for surface, and lambda often for linear. Okay? So it's a linear density. It's a density per unit length, and I'll go ahead and use lambda. Sometimes it's confusing because lambda gets used for eigenvalues and stuff like that. But that shouldn't cause any confusion here. Okay? And I'm not even sure, since the computer rebooted itself and we don't have copies of the text, I'm not sure what variable your text uses for a linear density. It might not be lambda, okay? That's not a variable, what symbol they use for the density function. Could be anything, so. Okay, but I'll use lambda, because it's not an uncommon usage, okay? So, we could find then the mass of the curve, or we could find its moment of inertia, okay? Or we could find its center of mass. We can do any of those things, okay? So, the question though that we're going to answer is just what's the mass? That's pretty straightforward. Well, what curve? Well, the curve is just this circle, just between 0 and pi over 2. So it's the arc of the circle. I should have been more specific. So the question is, what's the first thing we want to do? Well, your answer was a good answer. We want to take a single increment. That's the instinct we need. Okay? But before you can do a single increment, what do you need? And you quickly answer, well, we need a partition. Then the question is, well, what do we partition? You say, well, x and y? No, x and y don't depend on something else. And you say, oh yeah, t. All right? So it's t, our parameter, that we want to partition. Okay? So I'll just say we partition the interval of the parameter. Okay? Now we'll note that the parameter in this case is t. All right? So now we have the partition. We want to partition t. So we're going to use
You got it.
0 equals t naught less than t1 and so forth, less than tn, which equals pi over 2. Okay? And on the ith partition, the ith not partition, the subinterval of the partition, we have t sub I minus 1 less than t sub I star less than t sub I. Sample point t sub I star. That's a pretty universal notation, although I don't even remember if your textbook uses it. I know their Calc 1 text does, because I just got done generating assessments for Calculus 1, okay? Incidentally, you guys ought to get a copy of that so you can review what you should know about Calculus 1.
That'd be good.
And you know most of it, I mean, but you know, you forget details if you don't use them. And it's something you're going to need, very likely, just a foundation. So, matter of fact, I ought to get you one for pre-calculus too, because there's stuff you don't know about pre-calculus, because every pre-calculus course omits something, okay? And if you haven't needed that or used it yet, you very likely will. Okay, well, end of that digression, but okay, we partition. So, what do we do with that interval? What do we know about that interval relevant to what we're trying to find?